Hey everyone, and welcome back for another deep dive. Today, we're going to be taking a look at something pretty amazing, a brand new discovery that has astronomers kind of freaking out and rewriting textbooks. So yeah, we're talking about a planet so young, it basically makes Earth look like, a senior citizen.
Yeah, it's pretty wild.
This little guy, TIDYE1b, it's only 3 million years old.
Mm.
And to break it all down, we've got a fantastic article straight from the source, the University of North Carolina at Chapel Hill. And the article is called Youngest Planet Discovery Shatters Planetary Formation Theories.
I mean, it's not every day we get to look at the very beginning of a planet's life. And on top of that, one that just throws a wrench in everything we thought we knew about how planets form.
Yeah, no kidding. And that's why I'm so excited for this deep dive. So
Yeah.
I guess let's start with the basics. This planet, TIDYE1b, is going around a star in, the TIDYE1 system. And to put that 3 million years into perspective, that is crazy young. I mean, the Earth took somewhere between 10 and 20 million years to form. So it's like we're comparing a toddler to like a teenager in planet years.
Yeah, you're looking at a planet in its infancy. And discoveries like this are pretty much a gold mine when it comes to figuring out how planets come to be.
I got to ask, what's the most surprising thing about this whole thing for you? For me, it's got to be the fact that this little baby planet is already a total speed demon. This thing orbits its star in just 1 week. Can you imagine having a birthday every 7 days?
It definitely puts our 365-day year to shame, huh? But that crazy short orbit is a huge clue about TIDYE1b's environment and how it even formed in the first place. I mean, an orbit that tight, you're talking scorching hot temperatures, constant bombardment of radiation from its star. But the speed itself, that's what really throws a wrench in some of those old theories about how planets form.
Oh, yeah. This is where things get really juicy. So we used to think that planets, they form slowly and gradually over millions of years.
Right.
Kind of just like clumping together from a disk of gas and dust to swirling around a star.
Exactly. The traditional model. It's all about a calm and orderly process. Planets coming together over these vast stretches of time.
But TIDYE1b just went and ripped up that model, didn't it?
Yeah.
Forming way faster than we thought was even possible. So something else has to be going on.
It's got to be a more dynamic process, maybe even chaotic.
And then there's this other weird thing.
Oh, yeah.
The star's disk, the place where this planet was born,
Right.
it's tilted relative to both the star and the planet itself. Wait, tilted. So if the star is like our sun,
Right.
and the disk is like a flat plate around it, this plate is like at an angle.
That's exactly it. And that's what's so strange. It's like finding a pancake that somehow came from a tilted frying pan.
That's a great way to put it. Okay, so help me out here.
Yeah.
Why is this tilted disk such a big deal? What does it tell us about how TIDYE1b came to be?
Well, it just blows that pancake flat model of planet formation right out of the water. I mean, if the disk is tilted, how did the planet end up where it is?
Yeah. It doesn't really make sense, does it?
Like it's breaking all the rules. And that's why everyone's going crazy over this discovery. It's
Yeah.
like maybe there are other forces or things happening that we haven't even considered. Maybe gravitational interactions with other objects in the system. Or even the star's magnetic field could be playing a role.
It's almost like TIDYE1b is this little rebel, just going against everything we thought we knew about how planets come to be. I gotta say, I'm hooked.
It is a fascinating puzzle. And you know what makes it even more incredible? We're able to see this all happening thanks to a bit of cosmic luck.
Oh, okay. What do you mean by cosmic luck? Like, how did we even spot this rebellious planet in the first place if it's so young?
Well, young planets are notoriously hard to find. They're usually hidden within their star's disk. You can't even see them.
Like a cosmic game of hide and seek.
Yeah, exactly. But in this case, the tilted disk, the thing that makes it so strange, that's actually what helped us find it. It's like someone bent that pancake we were talking about, creating gaps and warps that let astronomers peek through. And that's how they saw TIDYE1b as it passed in front of its star.
Oh, that's pretty cool. So the tilted disk is both what makes the system unusual and what allowed us to discover it. Sounds like astronomers got a lucky break.
It was a lucky coincidence, that's for sure. But it also shows how clever and persistent these scientists are. They developed these incredible tools and techniques to overcome the challenges of observing baby planets. And look at the result. It paid off big time.
All right, now I really want to hear about these tools and techniques. How did they manage to detect something as young and as hard to see as TIDYE1b?
Well, NASA's TESS mission played a big role in all this, TESS, which stands for Transiting Exoplanet Survey Satellite. It's specifically designed to hunt for planets outside of our solar system. by looking at those tiny dips in starlight we were talking about.
So it's like a space detective looking for clues in the faintest flickers of light.
Exactly. And in the case of TIDYE-1b, Tess was able to catch it passing right in front of its star. That's what gave us the first hint that something really interesting was going on in that system.
I remember reading something about a special algorithm too, right?
Oh yeah. That's another crucial part of this story. The researchers developed a super specialized algorithm, they called it Notch, and it's specifically designed to detect planets around young stars. You know, stars that are still changing and flaring a lot, which makes finding planets even harder.
Wow. So it's like trying to hear a whisper in a noisy room. That's incredibly impressive.
And that combination, the cutting-edge technology and that clever algorithm, that's what allowed astronomers to pinpoint TIDYE-1b so precisely.
It sounds like finding this planet was quite the victory. But now that we know it's there, what's next? What are the researchers going to be focusing on now?
This discovery, it's just the beginning, really. Now that we know TIDYE-1b exists, the real work starts. Scientists want to dig deeper, learn more about its atmosphere, its formation history, and how it interacts with that tilted disk. It's like we've been handed this cosmic Rosetta Stone, and we're just starting to figure out what it all means.
Yeah, it's a chance to really put our theories to the test, and maybe even refine our understanding of how planets evolve. It's like we found this planet right in the middle of its teenage rebellion, challenging everything we thought we knew. But okay, what are the researchers hoping to find out by looking at TIDYE-1b's atmosphere?
So, analyzing what a planet's atmosphere is made of, that can tell us a lot about how it formed and what it's been through. It's like looking at a planet's fingerprints.
Ah, I see. So by figuring out what gases are in TIDYE-1b's atmosphere, scientists can piece together clues about the environment it formed in and what it's made of.
Exactly. It's a real cosmic detective story. And because it's so young, TIDYE-1b's atmosphere could give us a glimpse into the very early stages of how atmospheres develop, something we haven't been able to see before.
Wow. It's like having a time machine to study the baby solar system. What else are they curious about?
Well, there's also the question of how this planet is interacting with that tilted disk. We know it formed within the disk, but how is TIDYE-1b affecting the disk's structure and how it's changing over time?
Is there a way to actually see these interactions happening?
Yeah. Researchers are hoping to use some really powerful telescopes, like the James Webb Space Telescope, to get a closer look at the disk. They'll be looking for signs of gaps or rings or any kind of disturbances that might show the planet's gravity is having an effect.
So it's like watching this cosmic dance between the planet and the disk around it, trying to figure out the steps and how they're influencing each other.
Yeah, that's a beautiful way to put it. And this dance could give us some really crucial information about the relationship between planets and the environments they're born in.
This is all so fascinating. But there's one thing that keeps popping into my head. This planet is basically hugging its star, right? So it must be incredibly hot and bombarded with radiation. Is there any chance a planet in such an extreme environment could ever support life as we know it?
That's the million-dollar question, and one that scientists are definitely debating right now. While TIDYE-1b itself probably isn't a great place for life to exist, because of those extreme conditions, its discovery does raise some interesting possibilities.
Like what?
Well, if planets can form as fast as TIDYE-1b seems to have, it kind of suggests that planet formation might be a much more common thing than we thought.
Okay.
And it might happen much faster, too.
So more planets popping up all over the place. And some of those planets could be in the habitable zones of their stars.
Exactly. And that's why this discovery is so exciting. TIDYE-1b might not be a place for life, but it opens up the possibilities of finding other planets that could be.
So this one discovery is making us rethink the whole timeline of planet formation. And that could have huge implications for the search for life beyond Earth.
It's like this ripple effect. It's a huge shift in our understanding of the universe and our place in it. And it all comes back to this one little rebellious planet that's turning everything upside down.
Okay. Before we go too deep down that rabbit hole, let's come back to Earth for a second. What are some of the challenges that researchers face when they're trying to study a planet as young and distant as TIDYE-1b?
Well, trying to observe a planet that's millions of light years away is never easy. The light we get from TIDYE-1b is incredibly faint. And we have to deal with interference from Earth's atmosphere.
Right, it's like trying to hear a whisper from across a football stadium.
Exactly. And that's why telescopes like the James Webb Space Telescope are so important for this kind of research. They have these incredible optics, and they're up in space, away from all that atmospheric interference.
So this is just the beginning of the journey for TIDYE 1B, huh?
Yeah.
What are some of the key questions that researchers are going to try to answer in the coming years?
Well, they really want to delve into the composition of its atmosphere, look for more clues about its formation and how it's evolved. They'll also be studying those interactions with the tilted disk, trying to understand the dynamics of this crazy system. And of course, they'll be keeping a close eye on the planet itself to see how it changes over time.
It's like watching a kid grow up, except this kid is a planet that's millions of light years away. Speaking of growing up, do scientists think TIDYE 1B is still getting bigger, or has it reached its full size?
That's another great question. It's possible that TIDYE 1B is still pulling in material from its disk and gradually getting larger, or maybe it's already hit its peak and is now entering a more stable phase.
A cosmic mystery. Are there any hints that might tell us which scenario is more likely?
One thing they'll be looking at is how quickly the planet is clearing out its surrounding disk. If it's still gobbling up material, we should see gaps or clearings in the disk near the planet's orbit.
Like a cosmic vacuum cleaner just sucking up all the dust and gas.
Exactly. And by studying those interactions, scientists can learn more about the processes that control how planets grow and change.
It's mind-blowing to think we're actually watching these things happen in real time, millions of light years away. It really makes you appreciate how vast and complex the universe is.
It's humbling, isn't it? And it reminds us just how much we still don't know about the cosmos and all the incredible things it holds.
All right, let's zoom out a bit. We've been talking a lot about this one specific planet, TIDYE 1B, but what does its discovery mean for our understanding of the universe as a whole?
That's a great question. And it gets to the heart of why this discovery is so important. TIDYE 1B is shaking up some of our most basic ideas about how planets form. It's making us rethink our models and consider new possibilities.
So it's not just about this one planet. It's about what this planet tells us about the universe and its potential for other worlds like ours.
Exactly. TIDYE 1B's quick formation, the tilted disk, the extreme environment, it all points to a universe that's far more diverse and dynamic than we ever imagined.
And a universe that might be full of planets, some of which could even support life.
That's the hope, isn't it? To find another world out there that could be home to life as we know it, or maybe even life as we don't yet know it.
It's an incredible thought. And it makes me wonder, if a planet can form as quickly as TIDYE 1B, could life itself arise just as fast?
That's a really deep question, and one that scientists are wrestling with right now. If planet formation can happen on such short timescales, it definitely opens up the possibility that life could emerge elsewhere in the universe.
It's like TIDYE 1B is waking us up, reminding us that the universe is full of surprises, and we need to be ready to challenge what we think we know.
It reminds us that we're only just scratching the surface of what's out there. Who knows what other amazing discoveries are waiting for us as we keep exploring the cosmos.
All right, I think that wraps up our deep dive into the incredible world of TIDYE 1B. But before we go, I want to leave everyone with something to think about. If this one little planet can change our understanding of the universe so much, what other secrets are out there waiting to be found? What other amazing things are hiding in the vastness of space?
It really is an exciting time to be alive, isn't it? With every new discovery, we're pushing the limits of our knowledge and understanding our place in the cosmos even more.
And who knows what the future holds? Maybe someday we'll be talking about a planet even younger than TIDYE 1B, or one that breaks all the rules of physics as we know them.
The possibilities are endless. The universe is vast and mysterious, and we're just starting to explore its depths.
Yeah, it really makes you wonder what else is out there. I mean, if TIDYE 1B is already pushing the limits of what we thought was possible, what other crazy planets are we going to find? What other rule breakers are hiding out there in the universe?
That's the question that keeps astronomers up at night. Every time we think we've got a handle on how planets form, the universe throws us a curveball like TIDYE 1B.
It's like the universe is saying, nope, not even close.
Exactly. And that's what makes this field so amazing. There's always something new to discover, something that challenges our ideas and makes us rethink everything.
Okay, so this whole tilted disk thing, it's wild, right? It makes me wonder if our own solar system was ever that messed up. Like, could there be hidden planets way out there in the far reaches of our solar system, orbiting at crazy angles?
You know, that's not as crazy as it sounds. Our solar system seems pretty organized now, but things might have been a lot more chaotic back when it was forming.
So you're saying there's a chance we might have some long-lost planetary siblings out there, just hiding in the cosmic suburbs?
It's definitely possible. The discovery of TIDY-1b with its tilted disk, it opens up a whole new world of possibilities for what might be lurking in the outer parts of our solar system. There could be planets orbiting at extreme angles, or even planets that were captured from other star systems.
Whoa. That's pretty mind-blowing. Our solar system just got a whole lot more interesting.
It did, didn't it? And who knows what other secrets are out there waiting to be discovered. We have these incredible new telescopes and observation techniques. It really feels like a golden age for astronomy.
It's a great time to be a space nerd.
Yeah.
Okay, one last question before we wrap up this cosmic adventure. If a planet can form as fast as TIDYE-1b, does that mean there's a chance that life itself could emerge that quickly too? Like, could there be civilizations out there that are millions, even billions of years older than us?
That's the big question, isn't it? And while we don't have a definite answer yet, TIDYE-1b gives us some reason to be hopeful. If planets can form so fast, it suggests that the building blocks for life might be more common than we thought. And maybe the process of life starting isn't as rare as we once believed.
That's a pretty profound thought. It's like TIDYE-1b isn't just changing how we think about planets. It's expanding our whole view of the possibilities for life in the universe.
It really is, and it highlights how important it is to keep exploring and asking questions. The more we learn about the universe, the more we realize how much more there is to learn.
Well said. So to everyone listening out there, keep looking up at the stars, keep asking those big questions, and never lose that sense of wonder. The universe is full of surprises, and you never know what incredible discovery is waiting for us just around the corner.
Absolutely. Until next time, keep exploring.